Greetings, students. These notes will be the 4.1 notes on congruent triangles. Now, honestly, this is not the ideal way for you to learn this unit. It would be much better if we could explore these concepts together and maybe even discover them together using constructions, but needs must. So today I am going to go through these notes with you, giving you definitions and examples so that you will know the concepts well enough to be able to do your homework, and then hopefully we'll be able to go into them in more depth in class. So to start off with, we are going to be talking about congruent triangles for the rest of this unit and the different ways that we can determine for certain that triangles are congruent. So each of these initials up here in our title stands for a different way that we can determine that two triangles are congruent. So first of all, triangles we know are going to be congruent if all three sides of one triangle are congruent to all three sides of another triangle. So if three sides of a triangle are congruent to three sides of another triangle, the triangles are congruent. I encourage you to get out your compass and try constructing this. Draw yourself a triangle and then measure each of the lengths of those segments and reconstruct that triangle. It doesn't have to be oriented in the same direction, but it can be. And then find out if that triangle is congruent. So construct your triangle, or just draw a triangle using a straight edge, and then use your compass to mark off the lengths of those segments and make yourself a congruent triangle. I'm not going to do that today in the notes, although depending on how long we have for video notes, I may do that on another day. So an example. How about a right triangle? So we know that a right triangle that has lengths, let's see, we'll say A, B, and C, and then triangle DEF. So if we know, using our hash marks, that the two hypotenuse are congruent and these legs are congruent and those are congruent, then we know that the triangles are congruent. So another way we could put that is if we had a triangle using numbers A, B, C, and we know that this triangle has side lengths of 3, 4, and 5, well, and we have another triangle that we know the sides are also 3, 4, and 5. We know those are congruent. Now, notice that I've drawn in my right triangle, my right angle. That's just habit for me. I know this is a right triangle because it's a 3, 4, 5 triangle, but we don't actually need to know this in order to know that these are congruent. So that doesn't have to be there. All we need to know is if AB is congruent to what? DE, BC is congruent to EF, and AC is congruent to DF. Then triangle ABC is congruent to triangle DEF. Now, the order that I write that in matters. So notice that if I were to follow this triangle, ABC, it would follow the same path of congruency if I did DEF, right? So it's important to make sure that your sides line up correctly so that I know that A lines up with D and B lines up with E and C lines up with F. That's going to be important because those are considered to be corresponding parts of congruent triangles, and we're going to get into that later. Okay, the next things that we're going to talk about. So this was side postulate, SSS. All of our other theorems having to do with triangle congruency include angles. And so one of the things that we need to make sure we know is what an included angle is. An included angle is the angle that's between two sides, such that the vertex of the angle is the shared vertex of the sides, and the two sides of the triangle are the sides of the angle. So an included angle is the angle that shares a vertex with the two sides and has those sides for the sides of its angles. Okay, so in triangle KLM, angle L is included between sides LK and LM. Angle M is included between, BT/T stands for between sides, ML and MK. Okay, another concept we need to talk about is the notion of being opposite. This should be a review for you from any of geometry that you did in middle school, but just in case. When we talk about angles and sides, the angle that's not included in the sides is considered to be opposite it. So KM over here, this segment is opposite L. So KM is opposite angle L. LM is opposite what? LM is opposite K. And KL is opposite angle M. Okay, so that brings us to the side angle side postulate. In the side angle side postulate, we know that if two sides, I'm going to draw it first, what I mean by side angle side. So if we have two triangles, S, T, and U, now those don't exactly look congruent, and I should be using my straight edge. That is not setting a good example. There. All right. STU and O, let's see, M, N. So if I know that angle S and angle O are congruent, and then I also know that side TS and side MO are congruent, and finally SU and ON are congruent, I have what's called side angle side, because I have two sides and it's an included angle that are congruent to each other in two different triangles, and so I know that those are congruent. This is something that I want for us to practice with construction again, but for now we're just getting down the definitions and rules. So if two sides and the included angle are congruent to the included angle, to the two sides and included angle of another triangle, then the triangles are congruent. So if two sides and the included angle of one triangle are congruent to the sides and included angle of another triangle, then the triangles are congruent. All right, so in this example, we have TS congruent to MO. We have ON and SU congruent, so SU is congruent to OM. And then finally, angle S is congruent to angle O. Then, triangle TSU is congruent to triangle MON. Now, a note about this. So, notice all of these things that have to be true before I can say that these triangles are congruent. You should be thinking about proofs, because eventually you're going to need to be able to do proofs where you state each of these three things, and after you have, then using the side angle side postulate, you can conclude that two triangles are congruent. Or using the side angle postulate, you can conclude that triangles are congruent. That's what's coming your way. In the meantime, your homework is going to look more like deciding if two triangles are congruent by figuring out if they follow these rules. Okay, the next thing that we want to talk about is going to be angle side angle postulate, and I'm going to pause the video now and upload that in part 2.